The dramatic music builds. It's 2 p.m. We are live. Good afternoon, ladies and gentlemen and kids. Hello and welcome to Space. Oh, that came in a bit ferociously. Welcome to Space-to-Learn. This week, we are going to be joined by Bill McArthur. Bill is a retired US Army colonel and NASA astronaut. He's a veteran of 3 Space Shuttle missions and 1 Russian Soyuz mission. He's lived on both the Russian Mir Space Station and the International Space Station, which makes him the perfect person to answer your questions on this week's topic, making a home in space. So we need your questions. This is a live Q&A, so please pop them in the comments or, give us a follow on Twitter at ISSET_STEM and ask your questions there using the hashtag SpacetoLearn. We'll pick the best questions, and over the course of the hour, Bill will answer them live today. So don't just spam them. Don't write them a million times. Once is enough. We're going to go through the chat. We'll find your question and we'll try and answer it for you. Also, we've got a very special guest joining us who also wants to ask Bill a few questions. Jamaican sprinter Veronica Campbell-Brown. She's one of the most decorated athletes in track and field history. She's an 8-time Olympic medalist, and she's won 3 golds in Athens in 2004 and Beijing in 2008. She won the 200 meters 2 Olympics in a row. So she's going to be our special guest. But before we get to Veronica, let's head over to the main man himself, our astronaut, Bill McArthur. Are you there, Bill?
I sure am, Gendel. Good afternoon, everyone.
How are you, sir? Are you well?
I'm doing quite well, thank you.
Brilliant. Where in the world are you?
I live just outside Houston, Texas.
All right, fantastic. So it's the morning. It's like 8 a.m. for you, yeah?
Yes, it is.
Well, thank you so much for getting up early and joining us. I hope you're feeling fresh and ready for some questions. We'll give people a chance to kind of have a think. It is about making a home in space. So kids, have a think about that as your theme. So the most important thing, I guess, if you're going to make a home in space, you've got to get to space. How do you get to space, Bill? Should we start there?
Well, so how do you get to space? By flying on a rocket. And people ask, what's it like to fly on a rocket? And the short answer is, it's a blast.
Whee! I'm going to use that one. I'll use that one next week. Thanks, mate. Okay, well, brilliant. So shall we get cracking into some photos? What have you got for us? There you go.
Let's do that. Okay. So I did work for NASA. I've retired now, but let's talk about making a home in space. Well, what is a home in space? A home in space is called a space station. And the International Space Station, which is what flies above us right now, is not the first one. The first, as you can see, there have been many. The first was Salyut 1, which launched 49 years ago. And there were a whole family of Russian and American space stations until the Soviet Union launched the Mir space station, which you can see here. And today, Mir crashed into the ocean on purpose in 2001, several months after the first permanent crew went up to the International Space Station.
What year did the Mir go up? What was that? When did that first go up?
So the Mir launched initially in 1986 and flew for 15 years and was deorbited to crash into the southern Pacific Ocean in 2001.
No one was on it, thankfully.
Thankfully, no one was on it. And so we now have the International Space Station. We started building it in 1998. And people ask, well, how big is it? Well, here it is compared to a soccer pitch or soccer field. It's huge. It's over 100 meters wide, 363 feet wide. Goodness. So I've been very lucky in my, I misspelled adventures. I'm sorry. And so, sorry, kids. Yes, I do know how to spell that. Adventure starts with an A.
We'll let you off. We'll let you off.
3 of my missions actually went to a space station. My second flight did go to the Space Station Mir, We flew on board the Space Shuttle Atlantis. And this was the Mir station as we approached. Well, why did we go? We were the second space shuttle to go to Mir. And we took up this new part, this new little room to attach to Mir called a docking module. And the purpose of the docking module was to be the place where all subsequent space shuttles would be able to attach to Mir. Well, so being inside a space, pardon?
So it's kind of like a big like adapter ring. So everything would fit.
That is exactly what it is. Okay. And so after we attached the docking module, we had to open 4 different doors so that we could get inside Mir. And this is what we saw.
What a mess.
What a mess. It was a series of tunnels all connected together. And because things float, in the absence of having lockers or closets, you attach things to the wall. And so there's all this equipment that you have to sort of swim through to get to the main part of Mir. And here you can see the Atlantis crew in our striped shirts and the Mir crew in their spacesuits. We had 4 Americans.
Which one's you? Circle your face.
So here I am here.
That's you.
Yes, my hair was not gray in those days. This is Canadian Air Force Colonel Chris Hadfield.
Yeah.
Also, this is Luftwaffe Colonel Thomas Reiter from the German Air Force, and then 2 Russians, Sergei Avdeyev and Yuri Gudzenko. And so we spent a couple of days working with them. Then we undocked from Mir, and this is what Mir looked like for the rest of the time it was flying. And here you can see the part that we contributed.
Wow, that's amazing. All right, this seems like a good opportunity before we get into more of this, but what inspired you in the first place? When you were a kid, what made you want to be an astronaut in the first place?
Well, Kendall, yes, this kind of scrawny looking little fellow is me. When the first human beings flew in space in 1961, 59 years ago, the Yuri Gagarin became the first human being to fly in space. Now, at that time, I was living on a cotton and tobacco farm. This is the house I grew up on. And I was just some scrawny little kid. I had no idea that I could fly into space. And so the question is, how do you go from this to this?
What a photo. It's an amazing photo, that one.
Well, thank you. Yes, that's me just hanging around. And my dad served with the American Army in World War II, and then was in the American Army until he passed away. And so I wanted to be like my dad. I wanted to be a soldier. And so for university, I went to the United States Military Academy at West Point. And I thought, wow, look how glamorous this is, those cool uniforms.
Look
at
that.
So I learned something different my first day there. It was hard.
Is that you at the front?
That is me at the front. And if I look unhappy, I was very unhappy.
Yeah, you don't look like you've made the right choice there.
I was having second thoughts. But I stuck out the 4 years. And on June 6, 1973, we had a parade where we graduated. And so on that day, I left with 3 things. I left with a commission as a 2nd lieutenant in the American Army, a diploma, and a fiancée. And we have now been married for 45 years.
Love that photo.
So what happens to all cadets? As I said, I became a 2nd lieutenant in the American Army. I went to the 82nd Airborne Division and was a tank commander. Well, I was always interested in flying. And so at some point I went to flight school about a year and a half later. And I thought, hey, flying is really nice. You stay clean and comfortable. And well, sometimes as a pilot, maybe people have different ideas. And
Where was
so,
that? Where's that
so
photo?
this was at in Alabama. I had just been through a 2-day training exercise of trying to evade from enemy captors, and then eventually I was successful in escaping. But so I became a pilot. Here I am flying a reconnaissance helicopter in the Republic of Korea. And over the years, I discovered there was no airplane or helicopter I didn't enjoy flying. In 1978, NASA selected astronauts for the Space Shuttle program. And they selected 35 new astronauts, many of whom were different. Up until then, all NASA astronauts had been white men. This group of astronauts included the first women, the first African Americans, the first Asian American, and the first astronaut from the Army. And so I said, well, hey, maybe I can become an astronaut. And so I started applying for the program. And 10 years later, I did become an astronaut, which led to my journey to the International Space Station.
Wow.
And so on my last mission, as you can see on my mission emblem, there are two flags, an American flag and a Russian flag, because the International Space Station has been built by several countries. The most of the space station was built either by the United States or by Russia. And so I had to spend a lot of time in Russia at a little location called Star City. Star City at one time was a secret town in Russia. It wasn't on any maps, but here you can see it now. And astronauts and cosmonauts from all over the world go there to train. It has a much different climate than Houston does. And I very much enjoyed Moscow winters. My family got to come over and visit. And here you can see us in front of St. Basil's Cathedral in Red Square. And one of the things I really enjoyed about flying to the International Space Station is my crewmate, Russian Air Force Colonel Valery Tokarev. And by being part of an international crew, I was able to really learn a lot about Russian culture. And here we are in Valery's apartment. This is his wife, Irina. And this is another gentleman, Dr. Greg Olson, who was able to fly with us. He's not a professional astronaut or cosmonaut, but a businessman, scientist, and engineer who paid the Russians $20 million to be able to fly.
Wow.
So speaking of flying, as Gendel mentioned, we flew on board using a Russian Soyuz rocket and capsule, which is being stood up here out at the launch pad, which is in yet another country, Kazakhstan. And this launch pad is named Gagarin Start after Yuri Gagarin, the first human to fly in space. Well, so here we are out on the launch pad on October 1st, 2005. Valery, myself, and Greg. I sometimes say that Greg is a stowaway, and the Russian word for stowaway is zayats, which actually means hare or rabbit, and that's of course slang. But anyhow, it's 5, 4, 3. Well, I've got to count down in Russian. Dva, один, zazhiganya. And so now we launch. We go from not moving at all, and in 8.5 minutes, we're traveling at 17,500 miles per hour, 26,000 kilometers per hour, 5 miles per second. And here you can see Valery and I inside the rocket operating our spaceship, and look how steady and calm everything is. And in 8.5 minutes, suddenly everything is floating. If we weren't strapped in our seats, we would float right out of our seats.
It looks quite cramped in there.
Well, it is quite cramped in there. But I need to take a break here.
All
maybe
right.
this
Well,
would be a good time for some questions.
definitely, definitely. If you stop sharing your screen, we'll get into some questions. I noticed, like, you obviously knew the countdown in Russian. How good was your Russian in general?
Если вы полетите на российском корабле, if you fly on a Russian spacecraft, обязательно, you're obligated, говорить не очень плохо по-русски, to speak not badly in Russian.
Привет. That's all I know in Russian. Wow, that's
Привет.
good. Yeah, that's good that you've remembered it so well, though.
Well,
All right. Well,
I keep practicing that one.
yeah, you got to keep it fresh in your mind. You never know; they might call you up again. Okay.
Yeah.
Well, before we get to everyone else's questions, I believe it's time to say hello to our special guest, Jamaican sprinter Veronica Campbell Brown. Veronica, are you there? Is she there somewhere?
I am here.
Hi, Veronica.
Hi. Hi, how are you doing?
Good. How are you doing? You're not in Jamaica right now, are you? Where are you?
No, I'm not. I live in Williamsburg, Virginia.
Oh, okay. Nice. And how have you been in lockdown? Have you still been training and keeping fit?
Absolutely. Despite the challenges, I am training as best as I can and spending a lot of quality time with my daughter and husband and doing some biking and adjusting to the new normal, so to speak.
Aren't we all? Aren't we all? All right. Well, thank you so much for joining us. I think you've got a couple of questions for Bill, haven't you?
I do. Hi. Hello, Bill. How are you?
Hi, Veronica.
My first question, as an athlete, in order to prepare for an event like the Olympic Games, it requires a great deal of physical preparation to get my body in the best possible shape to perform at a high level. So as an astronaut preparing for a liftoff and prolonged periods at the International Space Station, how do you prepare your body for those missions?
Veronica, that's a great question because being in a microgravity environment is very, very stressful on the body. And so we're allowed as part of our jobs to spend some time in the gym or out jogging or cycling to maintain our fitness. I did several spacewalks during my career, and spacewalks require a lot of endurance. They last between 5.5 and about 7 hours. The spacesuit requires, it is very fatiguing to move because it's so stiff. And so we spend a lot of time not only doing aerobic exercise, but also doing resistance exercise.
Excellent.
And then on orbit, we have 2.5 hours per day to exercise.
Very intense preparation. My next question is, how do you readjust to Earth after returning from a space mission?
But how do we readjust? Very slowly. The most profound adjustment that's required is to become readapt to the presence of gravity, because the way our bodies perceive gravity affects our ability to maintain balance. Immediately after returning, we're not able to stand unassisted. Because we exercise so much, we have the strength to walk, but again, we don't have the ability to balance. And so they don't even allow us to attempt to walk for an hour or so. And then very slowly, with the assistance of medical personnel holding each arm, they allow us to start walking. And by the next day, you can move pretty much unassisted. And then we go through a rehabilitation exercise, just as if you're recovering from an injury, to try to rebuild our strength and coordination.
Very interesting. Thank you.
Well, thank you for
the questions.
Thanks for your questions, Veronica. They were brilliant. Are you so you were planned to go to the Olympics this year, and that's been put off till next year. You're still planning to go, is that right?
Yes, I am in training and hoping to make it to my 6th Olympic game. With it being postponed, I'm looking at it like as an opportunity for me to get into better shape, because being a new mom, it's taking me a little more time to get my body back into shape. So it could work in my favor having the Olympic postponed to 2021. So it is a dream of mine to make it. So I'm just going to keep working hard and hope and see what will happen.
You'll do it. You'll definitely do it. And another question: as someone who's kind of succeeded and got to the very top, what would be your advice to kids watching of how they could reach their potential in whatever they're doing?
So to be successful begins with having a goal that you want to achieve. Then you have to be persistent towards working towards those goals. And no matter the challenges you face while working towards achieving those goals, you have to be optimistic, knowing that if you work long and hard enough, you will eventually achieve your goals. It is also important to surround yourself with like-minded individuals for support and accountability.
Okay, fantastic. All right, I'd be mad if I didn't ask you this question for the kids. Have you ever raced Usain Bolt?
No, I haven't. But as a young girl, I normally race boys in my community.
Okay, well, maybe if you train hard enough, you can race him as like another little training race before next year.
Right, if you will adhere to the challenge.
Yeah, I reckon he's probably a bit scared of you. All right, Veronica. Well, thank you so much for joining us. Stay safe. Have a wonderful day.
Thank you so much. It's a pleasure. Nice to meet you both. Thank you.
All right. Take care. Thanks, Veronica. Bye. Wow, Bill. She's got loads of gold medals and everything. That's pretty cool. You're still the main man. Don't worry about it. All right. Well, let's get to some people's questions. We've had a few coming in. Okay. So Sky, aged 11 in Biggar, Scotland, says, what happens if you spill your drink in space?
Hello, Sky. Gosh, I love Scotland. That's where my ancestors immigrated from to move to the United States. But when you spill it, and it's difficult to spill your drink because our drinks are in an enclosed bag and generally have some type of straw, and we drink through the straw. But if you were to spill your drink, because there's no gravity, something called surface tension is the primary factor. And surface tension is why a liquid wants to stick to itself. And it's sort of like when you fill up a glass and you fill it too much and you see it just above the top edge before it goes down the sides. And so what will happen is the liquid will form just a little ball, or maybe 2 or 3 small little balls, and it will sort of float around in the atmosphere of the spacecraft and give you an opportunity to touch them with a towel or a napkin and absorb them. But if they hit the wall, they then kind of spread out in all directions as they're sticking to the surface of the wall. But generally, spills are not a problem.
Okay. Okay. Micropixel 2012. What a name. Asked, do the seasons on Earth apply in space too?
Hi, Micropixel. Well, of course they do, because as we fly over the Earth, we observe the ground and we can see the seasons on the ground. They don't affect, however, the environment inside the spaceship, because we spend about half of our time as we orbit each orbit, about half of the half of the orbit is over the northern hemisphere, and so half of the orbit is over the southern hemisphere, and we progress from eastern hemisphere to western hemisphere, and so we actually we are in all of the seasons all of the time.
Okay, I guess this kind of relates to this question from Abhijit Chatterjee. Is time in space slower?
Well, I would like to say, because of our speed, that if we talk about relativistic phenomena, time dilation and length, all these Einsteinian things, who knows? Maybe a few microseconds younger, but in reality, no, time is not slower in space.
That's a shame. Okay, well, you look young to me. You look a few seconds younger to me, Bill. Don't worry. Should we get back to a few more questions? I mean, we've done kind of the launch and getting to space. Should we talk a bit about what you do when you're in space?
Absolutely. Here we go.
If you start sharing again, there you go.
I will. So,
what's the next step?
I'm heading there. So let's talk about living and working in space. This was Expedition 12, Valery and I, and that's his name in the lower right-hand corner, Tokarev. That's not a P, that's not a B. Those are letters in the Russian or the Cyrillic alphabet, and so his name is Tokarev. So Valery and I, along with Greg, and here we are in our spaceship trying to catch up with the International Space Station. We flew for about 2 days in our Soyuz. And, Gendel made an observation that maybe it's kind of small inside. And yes, it
looks
is.
It there.
And so we were very happy as we got closer. And who do you think was inside the space station to take this picture? Well, this is the Expedition 11 crew. We were Expedition 12. Expedition 11 crew consisted of Sergei Krikalev from Russia, John Phillips from the United States. We spent about a week together with them showing us all the secrets of the space station that we hadn't learned in our training. Then Greg joined them and they returned to Earth. And so now it was time for Valery and I to begin the work that we were trained to do. One of our early tasks was to do a spacewalk. Here we are putting on, we had two types of spacesuits to use to go outside, an American spacesuit and a Russian spacesuit. Here we are putting on our American spacesuits. Now, the spacesuit consists of several parts. It's very big, it's bulky, it's stiff. When we designed these spacesuits, we assumed there would be a second or a third or a fourth or maybe even a fifth person to help you put the suit on. But Valery and I were on the space station by ourselves. Never before had any two people by themselves gone out and done a spacewalk because it's so hard to put the suit on. But we had some work that was very important. The space shuttles had been grounded after the crash of the Space Shuttle Columbia. And so we needed to do work to get ready for the next space shuttle to come.
So
My
Bill, when
suit
you
has
were,
Go ahead.
when you were dressing each other, is it like ultimate trust in each other to make sure that you're fastened, that everything's tightened up in your suit and you're dressed properly, basically?
Gendel, it is, but the good thing is we do pressure checks and leak checks. And so if we had made a mistake, it would really be obvious.
Okay.
But talking about a mistake, if you notice, we move everywhere using our hands. Well, what would happen if you fell off? Well, okay, you can't really fall because you're weightless, but you could float away from the space station. And so we have these wires called safety tethers, which are wound up inside this little mechanism with a spring. And so if you were to float off, the spring would pull the wire back in and therefore pull you back to the point where you've been anchored, and therefore you hopefully would not become lost in space. And so our task was to install this television camera so that we could actually inspect the outside of the space station without having to go outside, because it takes so much time to get ready for a spacewalk, to do the spacewalk, and then to come back in afterwards. Therefore, we spend most of our time inside doing experiments or doing maintenance on the space station. Here I am taking pictures of a sample of a liquid. And this liquid consisted of two parts. And so often, as we see on the ground, a liquid will separate into its different parts. Like if you leave a carton of milk out, over time, it will become very undrinkable because it will separate into the different parts because of gravity. So we're studying this liquid to see what would happen if there is no gravity. On the ground, scientists were studying the same liquid to determine what would happen in the presence of gravity. This is one of Valery's experiments, and perhaps one of my favorite, since I grew up on a farm. He grew some green beans. Now, we couldn't eat the green beans. Now, it's not because, as you might be aware from some of these science fiction movies, we weren't worried that the green beans would become monsters and eat us instead. but we needed to take the beans down to the ground for the scientists to study them.
Did you ever think that they wouldn't miss one bean? You could probably just have one bean and they wouldn't know.
Well, we're pretty disciplined.
You're too professional for that. I would have probably eaten the beans.
But speaking of eating, you may be familiar with an American holiday called Thanksgiving. And so this is Thanksgiving Day on the International Space Station. I'm spinning one of the most important tools on the space station, scissors, because we need scissors to open our food. And just like a meal I would have had if I'd been home in the United States, we had smoked turkey, mashed potatoes with onions. We had green beans with mushrooms, and we had a cranberry apple cobbler for dessert. Now, Valery is a member of the Russian Orthodox Church. As someone whose family was forced out of Scotland in the clearances in the mid 18th century, my religious background is Presbyterian. And so we said grace each in our native languages because meal times were a great opportunity for us to share the day and to also share our cultural experiences. Now, the green beans and mushrooms were dehydrated, so we had to add water to them. If you don't add enough water to the dehydrated food when you make it to make it sticky, it won't stick together and it won't stick to your spoon.
Oh, there's
you
a bit
have to chase it down.
He nearly lost it.
We all nearly did. This is officially a Progress resupply ship. It was the only resupply we had. It docked with us on December 23rd. And I'll let you in on a secret. That's what Santa's sleigh looks like in space.
Amazing.
So now, I don't know who you think this is. I see Santa Claus.
I see Santa Claus too.
Valery does not. Valery sees Ded Moroz, or Grandfather Frost. The Russian Orthodox Church observes Christmas on January 7th because the church uses a different calendar. On their calendar, it is December 25th, but on our calendar, it's January 7th. And so in Russia, instead of Santa Claus bringing gifts to good boys and girls on Christmas Eve, Ded Moroz brings gifts to good boys and girls on New Year's Eve. Again, what an interesting comparison of the two cultures.
That's nice. Now, you got to have two Christmases, though.
we got two Christmases. I think we flew at the perfect time and space to see all the big holidays. So now it was great having Veronica on earlier because she talks about the importance of exercise. How do you exercise? How can you run if there's no gravity? Well, here you can see Valery running on our treadmill. He's being held down by bungees attached to a harness. And by adjusting the length of the attachment, we can adjust how much weight, well, there is no weight, we can adjust how much force there is. Here you can see, and you notice he had exercise equipment on. I mean, he had data gathering, medical equipment on. Here I am riding a stationary bike, also with equipment on to measure how much exercise we had. We also could lift weights. Oh gosh, that's right, there are no weights. But this mechanism helps put a downward force in this bar so it feels just like weightlifting. Then we were such a lucky crew. Not only did we get to do a spacewalk in the American spacesuit, we got to do a spacewalk in the Russian spacesuit. And people ask, well, which one did you like better? My answer is, I liked going outside. Both spacesuits kept us alive because there's no air around us. It's hot in some places, cold in others. And so once you learn how to work in one spacesuit, you can work in the other. And so just like in the American spacesuit, you don't want to fall off. So it's important to just be very careful as you go hand over hand move slowly. That looks a little too fast.
That does look quite fast. He's floating off.
Somebody slipped off. So remember that safety wire? Well, the safety wire is missing.
Oh no.
Houston, we have a problem.
Oh, a big problem.
Someone is lost in space. Well, I'm here on screen, so that must be John Smith. Oh, wait, we didn't have a John Smith on the crew. This actually was an extra spacesuit we had. And the neat thing is the Russians, when they finish using their spacesuits, they just throw them away. So we had this extra spacesuit. We stuffed it full of dirty clothes and towels so it looked like a person. And then when we went outside, Valeri jettisoned it, cast it aside, and I got on the microphone and I said, "Houston, help, help, help."
You were playing a prank on Houston.
Okay, well, I guess if we'd really done that, what would have happened? They would have made us come back early. We would have landed on the steppes of Kazakhstan, and there would have been no one there to bring us home. Now, this is actually an experiment called SuitSat, or Spacesuit Satellite, Radioskaf in Russian. And what we had done is we had attached a transmitter to the suit, put a battery inside, and when we jettisoned it, the transmitter broadcast a message on an amateur radio frequency in a message recorded by young people from around the world, such as our audience, a message of world peace, hope, and cooperation. And John Smith, or Ivan Ivanovich, orbited the Earth for about 6 months before re-entering.
So he's not still floating around up there?
Still not floating around. But speaking of the Earth, it is magnificent. You know, this is the only planet which we know has life on it. And so this is our home, and it's a very, very important planet. So it's beautiful, and we need to take care of it. And my favorite, one of the things I really love is looking at this little fuzzy band, which is called the atmosphere. And that's why we can live on this planet. And we see lots of things from space that are just beautiful and fascinating. This is the moon's shadow, a total eclipse of the sun. We're right now over the Northeast Mediterranean, and the ISS flew right through that shadow. A hurricane in the Gulf of Mexico. Glaciers, rivers of ice flowing down the Andes Mountains in South America, in the southern tip of South America. These are called the Patagonian glaciers. This is Arawanga Impact Crater, which is located in the Sahara Desert of northern Chad. It's 11 miles across. The thing that created this was a comet or an asteroid about 1 mile across. And things like this hit the Earth about once every million years. Why it's really important that we study the universe, we study the solar system, because it will be our current pandemic would pale in comparison if we get hit by a rock like this again and are caught by surprise.
When did that one hit then? Do you know?
And so this one hit, I think, several million years, several 100 million years ago.
Okay.
And the one that caused the dinosaurs to become extinct hit about 66 million years ago.
Okay.
Oh gosh, where's this? Does anybody, Gendel, do you know where this is?
I can see my house.
Oh, there you go. And so here, of course, is the Thames River, and you go up into London. Oh, and I think our first question, wasn't that from a young person in Scotland? And so we come up here and we can see where Glasgow and Aberdeen are. And now it's very interesting. The space station doesn't fly any further north than about London. It doesn't go any further north than 56 degrees or further south than 56 degrees. And London is just about 55 degrees. So maybe if you like a slightly nearer picture, here it is. Okay, so that's sort of what it's like living and working on the space station. Are there more questions?
There's plenty. Yeah, we better get cracking. We're running out of time here. Okay, let's get in some questions. Aaron, age 10, are there any aches and pains you experience with weightlessness in space that you wouldn't get on Earth?
Well, Aaron, the aches and pains actually feel very similar. And so when you first get up into space, some of the discomfort, it's just that the causes of the discomfort may be a little different. And so when you first get into space, the gravity's not pulling the fluid, the blood down to your legs and feet. And so it shifts up into your head. And so your head has a sense of fullness, much like you have a head cold. One of the things I experience is because without gravity pulling you down, your back gets a little bit longer. And I am an inch and a half taller when I'm in space. And initially, that means the muscles in the lower part of your back have been stretched out. And so that can cause a very slight amount of backache, much like when you first go out and work in the garden in the springtime.
Okay. Martin McLean asks, I guess this kind of, you touched on this a little bit with John Smith, but do you play any practical jokes with your crewmates on the space station, or do you need to keep it professional all the time?
Oh gosh, if you were maintaining a professional relationship all the time, it would be boring. And so, sure, we do practice some jokes. We do have some practical jokes and some teasing, but it's sort of like, how do you live in isolation, like many of us have done during the pandemic? You try to be very sensitive to the feelings of your crewmates. And so good-natured fun is okay, but you really don't want to do something that would create hard feelings.
When it was just the two of you, like for so long on your own, did you ever kind of fall out, or were you always friends? And
oh, no. I was, because I was the commander, I think I sometimes did things that caused a little more stress for Valerie than I should have. We had an unusually high level of carbon dioxide in the cabin. We thought it was okay. We now know maybe that isn't the case. And one of the symptoms of having elevated carbon dioxide levels is becoming irritable.
Oh,
and
really?
So there were times I was irritable, unfortunately, and for that to Valeria, I apologize. But how we combat the isolation is I could make a phone call home almost any time I wanted to if we had the right satellite coverage. And so I called home nearly every day, and at least once a week we had a video conference. Not as good as this one is, but we did have a video conference once a week with the family.
Great. Okay, Madhav, age 10, asks, what happens when your spacesuit runs out of air?
Oh goodness, we pay very close attention to the amount of air in the spacesuit. Now the spacesuit actually has pure oxygen in it, and so we can see the pressure of the oxygen at any time. Data is going to the ground so they can see it. And so if they were concerned that we were running low, they would just make us come back in early. But also we have something called a secondary oxygen pack that's in the suit. And so if your primary oxygen supply were depleted, you would go on your secondary supply and immediately go inside.
Okay, so you've always got the backup. Laura Cox asks, do the astronauts fly the rocket, or does a pilot get an exclusive trip to space?
The rocket is computer controlled. There are emergency procedures if the launch had to be aborted, in which the pilot may have to do some manual flying. But those have never happened. And even the few abort, the Russian space program has had a couple of successful in-flight aborts. And again, the computers really controlled everything. There is some manual flying when you actually get close. There may be some manual flying when you actually get close to the space station.
Okay. Oliver, age 6 from Scotland, another person from Scotland, would like to know, when will we be able to live on the moon?
We hope to return to the moon in 4 years. And so if we have the commitment from enough nations working together, I think maybe we could be living on the moon in 10 years.
Wow.
Maybe 20 to 25 years, we could go to Mars. And if we go to Mars, once you get there, you must live there for 15 months before you can return home.
Would you like to go to Mars?
I think I would. I don't know if I would enjoy it enough to want to leave my grandchildren.
No, that's quite a long time to go. But Oliver, don't worry. Scotland's really nice. You don't need to go to the moon yet. Take you to, maybe in 10 years you can go.
I am particularly fond of Scotland.
Yeah, stay there for now. Okay, Mohammed Rizaul. I don't know if I'm saying that. I'm sorry if I'm saying your name wrong, Mohammed. He asks, what was the scariest thing you did in space?
Gosh, Mohammed, I remember being excited in space sometimes. I don't remember being scared. And it's because I think we're so well trained, and we have a sort of view that we will deal with any problems or emergencies we have. And if it's a problem we can't solve, well, that's just the risk that we've accepted. Maybe gosh, it's very exciting going out, but it's not scary. Perhaps the biggest surprise I had is when the alarm went off one day and it said we had an ammonia leak into the cabin from one of the outside systems. And the ammonia we had, if you breathe it in, it would be fatal. And so an ammonia leak is one of the most serious emergencies we train for. And so I immediately went through the procedure, sealed off all the hatches in the space station, got to where Valery was located in the Russian service module. And he gave me the look of, what are you doing? Because with the alarms blaring loudly, I could not hear the ground say, it's a mistake. It's a false alarm. Don't do anything.
Wow. God, that must have been scary. Okay, we'll do one more quick question, then we'll finish up the last of your pictures you've got. Niverithi? The difficult names today. Niverithi. I hope I'm saying that right as well. How hot are the stars? Good question.
My goodness, the stars are millions of degrees. Goodness. That's why we could never actually land on a star. Stars are really massive nuclear reactions. They are fusion reactions in which atoms of hydrogen in great temperatures and pressures are squeezed to become atoms of helium, and it releases millions of temperatures at millions and millions of degrees.
So you're not getting close to a star anytime soon, are you?
No.
No. All right. Well, let's quickly let's see the last of your slides and finish up. This is about getting home. Is that right, Bill?
Yes, it is. Okay. Returning home. Gosh, it's a lot like being on a vacation. You're just so happy to be there that you're not sure if you really want to return or not.
Got to come home sometime, Bill.
Yes, you do. So on April 1st, we look out the window and we go, oh my goodness, here's another spaceship. Are we being visited by aliens? No, we're being visited by our replacement crew, Jeff Williams from NASA, Pavel Vinogradov from Russia, and Marcos Pontes, the first astronaut from Brazil. And so here you can see we have three countries represented, Russia, Brazil, the United States. Oh goodness, and I flew with a Canadian astronaut, I flew with a Japanese astronaut, I flew with a German astronaut. I love I think the international cooperation to explore space is one of the most valuable things that happen. Exploring space shows that nations, even with competing interests, can cooperate. And so after a week, Marcos joined Valery and me on our Soyuz. I'm sitting right behind this window, and we left the International Space Station to come home. Now, the Soyuz has three parts, this front module, a back module, and the descent module in the middle. The descent module is the only part that comes back. And here you can see the descent module in the front glowing white hot. The other two modules have burst and they're burning up in the atmosphere. From 6.5 kilometers down, we're under a parachute. Ooh, right on target. There's the search and recovery helicopter.
Going down fast.
We gently float down for a nice soft landing.
Oh, it didn't look that soft a landing.
Well, it didn't feel that soft either, Gendel, but it was nominal. It was a normal landing. And so all that dirt and debris is not from the impact. It's really from these little downward firing rockets that help slow us down at the last minute. And as I mentioned, we really, in my answer to Veronica, we really can't walk yet. And so they lift us out of the capsule and they carry us over, put us in chairs, and now give us a little bit of herbal tea. And gosh, and it was 26 degrees Fahrenheit when we left, so it was cool. The air was refreshing. We're out on the steppes, the plains of Kazakhstan, and we were really, really excited to be home. They gave us a quick medical checkout, put us in helicopters, flew us to a local airport, and then we got on a Russian commercial airliner and flew back to Moscow to be reunited with our families.
Amazing.
Wow. So, gosh, what's next? Well, this is what the International Space Station looks like today. As I pointed out earlier, it's bigger than a soccer field. Still, the only way to get there is on a Russian Soyuz. Resupply is still with the Progress. The last Japanese H-2 transfer vehicle just launched, another resupply ship. These are two resupply ships, Northrop Grumman and Elon Musk's SpaceX, that do resupply launches from the United States. Soon, the Sierra Nevada little space plane Dream Chaser will be doing resupply.
That's cool.
Later this year, hopefully there'll be the first demonstration flight of the Boeing CST-100 Starliner. And tomorrow at about, I guess it's going to be, if I can do the math, at about 10:30 at night, London time, Elon Musk's SpaceX Crew Dragon will launch with two astronauts, Bob Behnken and Doug Hurley. After they launch, 19 hours later, they will rendezvous and dock with the International Space Station, the first flight with astronauts to launch from the United States in almost 9 years.
Wow, that's incredible.
But why are we doing this? We're doing this because we and our international partners want to return to the moon, flying on the biggest rocket ever built, the Space Launch System, on board the Orion multi-purpose crew vehicle. And by the way, the service module at the back part of Orion with these 4 solar arrays is built by the European Space Agency. And this is part of a program called Artemis. So we remember Apollo was the program that took the first human beings to the moon. And it's named after the god Apollo. Artemis is named after his sister, the goddess of the hunt. And so, and if you see the timeline, our goal is to have the next people on the moon in 4 years. So the question is, how can the sky be the limit when there are footprints on the moon? So let's see if we can take a few more questions, Gendel.
Yeah, let's do it. Let's get into it. We're running out of time very quickly. Okay. Emaniac the 7th said, "Can you see New Year fireworks, and what do they look like from space?"
So if the weather is good, you might be able to. I was not able to see any.
No. You were too busy hanging out, opening your Christmas presents on New Year. Anyway, Plot McAstro, if there is eventually going to be many people living in space and other planets, how will scientists and governments decide who will go up?
So initially, many of the same criteria will be applied that are used now to select astronauts. And so we'll select based on education and work experience. And so what are the skills that will be required? So some will need to have the skills necessary to operate the spacecraft and the landers and the habitats. If we're on other planets, you may have seen the movie The Martian with Matt Damon. So he was a botanist. And so we will need, if we're going to grow our food on planets, we'll need people with the skills to do that. We'll certainly need physicians to help with the medical requirements for the crew. We'll need people, engineers with the ability to build structures. And so I think the criteria will be to select for the skills that will be required there, and also keeping in mind that you will be very far from the medical support we're accustomed to here. So we'll need to send people who are healthy.
Okay. Heidi, age 12, asks, what does it smell like in space?
Well, Heidi, there are a number of different smells inside the space station. Sadly, if you've just done your exercise and you've hung your clothes out to dry, if you go by those, it will smell just like dirty gym clothes. But most of the air purification, the air conditioning system in the space station is very, very effective. And so mostly the air smells very good. Now there was something unusual I found when I would bring my partners back in from doing a spacewalk. There tended to be a very unusual metallic smell that we think came from the metal because it was exposed to some of the atomic the oxygen ions and things in space.
Oh, wow. Okay, Savit's a bit of a regular. Hi, Savit. What was the most complicated thing in your second mission?
And Savit, so a couple of things come to mind. One was simply preparing for the spacewalks. We also relocated our Soyuz to Soyuz twice, and that was a very complicated procedure because we had to prepare the space station for the possibility that we could not redock and enter. One of the most complicated experiments I did was growing protein crystals in the ISSET glove box because there were a lot of small parts to find.
Okay. Nick says, hi, I'm from India. Why is India not part of the ISS?
Well, Nick, of course, India has a very active space program. I think it's the Indian Space Research Organization, and I think it's really very possible that India at some time could become a member of the ISS consortium. Of course, several people of Indian heritage, sadly, Kalpana Chawla, who perished on Columbia, was of Indian heritage. Sonny Williams, who will be one of the upcoming commercial flyers, also has an Indian parent. But I think it has very much to do with the opportunity to contribute a significant component to the International Space Station.
Okay, right, let's do one more question. Let's ask Ved's question, age 10. He's got about 3 questions in one here. How many solar systems are there, and how many of them do we know, and how many will we come across in the next 100 years?
So, of course, there must be billions of solar systems because the universe is huge. There are billions, there are billions of galaxies, and the galaxies consist of billions of stars. And some number of those stars will have solar systems around them. We even have identified some solar systems with planets that are in what's called the Goldilocks zone. Goldilocks? Well, remember Goldilocks? Parts too hot, parts too cold, parts just right. Bed too hard, bed too soft, bed just right. And so there are some planets that are located in a relationship to their star, their sun, that are in a region that is just right temperature-wise to sustain life as we know it. And so how many will we come across in the next 100 years? Well, we will not go to any in the next 100 years. The distances are too great. Will we discover more in the next 100 years? Undoubtedly, astronomers will discover more solar systems.
All right, wonderful. Okay, well, that is pretty much all we've got time for, Bill. Thank you so much. Have you got a final message to all the kids? Any advice to any wannabe astronauts out there?
I really do, and it's very similar to the advice. It's very similar to the advice that we got from Veronica, and that is really you are the future. So set goals. Because we're going to rely on you to solve all the Earth's problems. So set goals for yourself. Learn to cooperate. Learn as many additional cultures as you can, because we as a community of nations are going to make the future successful collectively. As Veronica said, set goals for yourself. I applied for the astronaut program 7 times. And so when you set a goal, don't accept failure. If you don't succeed initially, reassess, look at what you need to do differently, and try again.
Exactly. Never give up. All right. Thank you so much, Bill, for your time. Have a wonderful day, and we'll talk to you again soon.
Okay. Thanks, Gendel.
Take care, dude.
Bye-bye, everybody.
See you later. Well, there you go. Bill McArthur, everybody. Thanks, Bill. That was wonderful. Thank you for your questions. And thank you again to Veronica for her questions as well. Unfortunately, this is the last Space to Learn in the series, but don't worry, we'll be back. So please make sure you hit subscribe and follow our social media channels at ISSET_STEM on Twitter and Instagram. Until the next time, this is Adam Gendel, spacing out. Stay safe, everyone. I'm off. Spacing out.